very good morning to all of you. Today, what we are going to see is we will be running an ETL process in Pandas locally, fetching data from Postgres, which will be in a Docker container, putting it to a warehouse. In our case, it will be AWS Redshift. We will be using Pandas library for this step. So that was a small introduction for it, and we'll move on now. So I will walk you through the script part. These are some environment variables, credentials. I'll talk about them later. We are using Pandas Redshift connector, and this is for a schema. So what I am going to do is based on this schema. Have a look, pause this video, and refer to this schema for a better understanding. I will talk through what I'm going to do. This is based on a retail organization. It will represent all these tables. What I am going to do, what we will be going to do together, we will calculate top products, top categories, and top departments, all three based on revenue. This will be in our transformation step, and we will push this three tables to our warehouse. Fine. So we will move on. This is our source, as I told you. This will be in my Docker container. Hopefully, yes, it should be running. Okay. So what we did first, we we took all the tables as is. Okay, fine. So now, if you have a closer look to schema, we need to find highest selling product based on revenue. We have these order items which will have these subtotals. So we will be making three joins, one with this one, order to product. They are joined with categories. This is the second join, and they are joined with departments. This is third join. So product orders, categories product orders, and department categories product orders. These are three joins which are required. So now what we are doing, we are taking product orders, grouping it by product ID and name, calculating revenue. These are aggregate functions, group by functions. These are all provided by Pandas. Sorting, and that's it. Same categories, or I should show you as well. Fine. You saw this product name based on their total revenue. Okay. Now we have category product orders and grouping by category. That's what we want. Same summing revenue and sorting. That's it. We'll see categories. Okay, that is our category information. Same with departments. So that's how we see what departments are performing best in terms of revenue. Fan shop is here for that. Okay, fine. We have column type map. So what we are doing, we have written a function which will push or take a data frame and push it to our warehouse, Redshift in our case. So what it does, if a column type or data type of a column is object, we know its string, we map it here. So that is these are all we can obtain from Redshift documentation. These are all available there. These values, what I'm talking about, values, keys are the pandas ones. Okay. So we connect to Redshift. I'm going through function which will be pushing our data frames to Redshift. So this function creates a table, takes care of that, executes, creates one single insert statement for rows, because if we do it for each row, then we may occupy a connection for a longer time, depriving others. Maybe I believe that is better practice. You may comment if you have any other opinions. Fine. Executing that. That's it. We are calling this with three data frames, three table names. What we want. So where were we? Executed. Okay. Fine. Now we'll go through some warehousing concepts. What are they before executing this? Okay. So that's it for the script part for now. So I believe I should tell you what are data warehouses. So these are similar to our normal databases, but what we see is databases are for transactional purposes. Fine. But warehouses are for collection purposes. Imagine uh, executive reports, analytics purposes, stable data in case we see. So you see somewhere you will find a good visualization chart which will show that difference. Okay. Another term comes across to us is data lake. Fine. What is lake versus warehouse? Data lake versus data warehouse. Data lake is a set of data. Okay. Similar to you collect some servers, run databases on them. You may, that is practically a data lake. But what is a warehouse? Warehouse provides you resources to operate on those infrastructure, compute, network, takes care of all that. That is a data warehouse. Fine. I will show you another example. See, there are these nodes. Okay, there is a master node and others are compute nodes. So we see in the end these are Redshift stores that data on S3 itself, but we interact only with a master node. That is an important thing to remember. We run queries, we put data, execute, retrieve, all that thing we do only with the master node. That is our single point of contact in this system. Okay, where this AWS comes from, we'll talk to we'll talk that in just a bit. But this I kept for better understanding for us. So we talk about the raw data. For us, raw data comes from a Postgres. Fine, where is that? This is our raw data, Postgres instance. Okay. ETL, what is our ETL? This is our ETL script. Okay. Next, this is our Redshift. Correct. So a Redshift can have same as database, but with greater capacity and number of consumers. Database reports, executive reports, management reports, all that. Data analytics use cases, those are better if run on Redshift. Considered a stable data as compared to database, which is transactional, uh, similar to some home at applications, all that. Fine. So, what is Redshift? It is a managed data warehouse service. You can go to here, you can see what that is. Uh, you will get a better understanding of what it is. So, what we have done, we have created a Redshift cluster. So, this cluster provides all this infrastructure which we need, of which we will be only interacting with master node. A question comes, how do we interact with a master node? Fine. We interact with a master node using editor. You see cluster name, demo Redshift cluster, same. So with this editor, we can run queries on it. Okay. So if we refresh it, we see there should be zero tables, no data. Okay, we don't have any data. So what do we do? Okay, these are not relevant. How are we connecting to Redshift to put data what we want? Fine. This is endpoint, host, port, database, credentials. We get credentials when we are creating a cluster. So that time we get, and we can see it later also. That is okay. So now we will put data onto Redshift. Keep a tab. We are having 0 tables. Fine. We are a clean slate right now. Done. 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 Fine. So now we are done with loading process. So wait is over now. We see 3 tables. Okay, that's what we gave name for. Top products, top categories, top departments. Fine. What is it? See, this is our thing. Categories, products, see the value, and departments. This is lesser data. Okay, meanwhile it loads. I will show you a good thing which I found about pycharm. So instead of using plain Jupyter notebooks, I recommend you to use pycharm to get you a better understanding of what is the data you are working on. So you see this chart view. So without using other charting library, you can create these charts here. You understand what the data is, those things. So which one contributes most? So this is something better. I felt. Why? Why? Okay, yes, we got it. These are our top departments. So this was that. I'm checking now if I'm forgetting to tell you anything else. Okay, nothing else. We are over. So that was it. This was a Redshift. You see, there are some properties. These are all credentials you will get here. Security. One more thing to remember is either you make it accessible from anywhere, you can do it here, yes, or attach a security group which can be accessed from everywhere. The zeros, right, it represents everywhere. Okay, that was it. So if you have any questions, suggestions, ideas, collaborative ideas, or simple interactions, you can ask them anytime on comments. If you know me, you can reach out to me. That's it. Thank you. We'll meet some time else in next video. Probably I will see what I can do, but give me ideas what we can cover next. That's it. Thank you for joining my log. See you soon. Bye.